Hi, good evening, everyone. I hope my voice is clearly audible. You can simply raise your hands to confirm this. All right, great. So, guys, we are waiting for few more candidates to join in here, right? Let's wait for 2-3 more minutes, and then we'll directly proceed ahead with the discussions.
Hello, Mr. Rohit Raj. Welcome back to your
All right, once again, good evening, everyone, and welcome back to your sessions, right? So, we'll proceed ahead with the discussions where we left in yesterday's session. Right. So in yesterday's session, we were discussing about the pivot tables, right? We saw at various levels how pivot tables can be created and which will help you to understand the data in a better way, right? And perform good extensive data analysis, right? Taking the discussion forward, today we'll discuss about the percentiles, which is just an integrated or you can say extended part of percentages, right? So I hope everyone knows how percentages are calculated over a given set of data, right? And percentiles are just an extension of it, right? So you can simply raise your hands if you already aware of how percentages can be calculated. We have already seen the same in the very first session itself, right? Now moving ahead with this, talking about the percentiles here, right? Talking about the percentiles. So before we dive into percentiles, let's discuss a little about or just an overview of the percentage, right? So percentage is nothing but it is a fraction of a right? So basically, it is just a fraction, or you can say it's a sub part, right? It's a sub part of your complete given part. For example, let's say if someone scored 83% in their, uh, maybe in 12th standard, right? So this is basically he was able to achieve or he was able to solve 0.83, which is fraction out of 100, right? 0.83 part of 1, right? Or you can simply say it's 83 parts of 100, right? This is exactly what percentages mean, right? Now here, if you look closely, percentages basically tell you the exact output, right? Or exact amount of, let's say someone scored 83 percentage, it's basically the exact amount or exact score it is giving you, right? This is the exact quantity, right? At the other hand, percentiles here, percentiles do not tell you about the exact quantity, right? But it tells you about the position, or it's better to say relative position. Right? There are some exams. We'll take an example of an exam, right, where the results are declared in the form of percentiles. So let's say someone scored 83rd percentile. Right? So what does this basically mean? This basically means that let's say this is the score, right? And score is of a score holder, right? So we'll have the respective score holder as well. For example, let's say if someone scored 83%, we have that particular person who scored 83%, right? In the similar way, if someone scored 83rd percentile, right? So this is basically, we also have a holder, right? The score holder who has scored 83rd percentile of score. And this basically says that this particular score holder was able to achieve, let's say he was able to achieve marks more than 83% of attendees, right? And he was able to achieve, or in other terms, this could also be mentioned as he was able to achieve marks less than 100 minus 83, right? Which is nothing but 17% of attendees. Right? This basically, percentile basically tells you about the position or relative position, right? In other terms, we also call this as rank, right? Based on the position, you can simply assign a percentile rank, right? So this is basically the overall idea behind percentiles, right? I'll just give you a quick overview that the percentage here is basically the fraction of full, right? It's a fraction of full, which basically means if someone scored 83% in their 12th standard, right, or any given exam, he was able to solve, or he was only able to achieve 0.8 part of one, right, or 83 parts of 100, right? Both of these are equally valid statement, right? Which is basically, it's giving you the exact quantity here, right? 83 parts, right? At the same time, percentiles here will give you idea about the relative position, right? And this relative position is nothing, but it will majorly tell you about the position that you hold in the hierarchy, right? And this is the hierarchy of all the attendees who have appeared for that particular exam, right? Okay, so if more than one person scored same score in percentile, so is percentile going to be same? Yes, if we have, if let's say if the percentiles are same, right? Percentiles are always defined for a range of values. We'll discuss about this, right? So if two people hold the same percentile, they basically stand at both of them basically stand at equal position, right? Equal relative position with respect to each other, and they'll be these two statements are equally valid for both of them, right? If more than one person has the same percentile of scores. All right, so it basically tells you about the position itself, or you can, in alternative terms, you can say it can tell you about the rank. Right, so this is the basic difference between percentage and percentile, right? Let's take one more example here, right? So let's say, guys, I hope my voice is clearly audible, right? You can simply raise your hands to confirm this. Right, it's loud and clear. All right. Okay, so guys, if any one of you is facing this voice lag issue, it's advised to rejoin the session once, right? This will resolve the problem of interference, right? You can simply rejoin the session. Maybe I can give you 5 minutes, right? Simply drop out from the session and rejoin from your LMS. right? So 5 minutes. All right, we'll resume the session at 9:45 IST. All right, take 5 minutes and please rejoin the session if you're facing this voice lag issue. Guys, please wait. We'll resume the session at 9:45, right? A few of the attendees are rejoining the session, so let's wait for them. Right, and those of you who have rejoined, you can simply confirm whether you are able to hear my voice clearly now, right? Simply drop a yes or a no in the chat section. All right, guys, so let's resume our session now, right? I hope everyone is able to hear my voice clearly, right? So basically, the overall idea of percentiles here is to tell you about the relative position, right, of any attendee with respect to all the everyone who has appeared in a particular exam or the part of the population, right? So here, let's take one more example, right? So before that, you could simply confirm how many of you are a working professional as of now. You can simply raise your hands. All right, great. So, guys, you'll be able to relate this in a better way, right? So here, let's say if I, any working employee, any working employee is working for any organization here, right? And in an organization, there's basically a complete hierarchy of all the employees working, right? You'll have maybe the top management, right? The board of directors, presidents, etc. Right? Then you have vice presidents, then you have management, right? Then you have mid-level managers, team leads, and then executives, and so on. So this is basically hierarchy in any organization. right? And each of the, let's say, all the employees falling into different hierarchy, right? They're receiving different salaries from the organization, right? And we have already seen this when we were discussing about the pivot tables, right? The sample data that we are working on is basically a employee data of a particular organization, right? So here, as we have seen yesterday as well, that people holding the same designation in the same organization, right? Uh, they are basically drawing different compensation for the services they are offering to the organization, right? That's basically the salary we are talking about here, right? So it's same designation, different employees. The salaries are different, right? So which is why there will be a range of values between which employees are being offered salary, right? And range is always defined as, let's say, if we, whenever we want to talk about range, range is always defined as the minimum and the maximum values, right? So always the range will be between minimum and maximum values. You can understand range like this. For example, let's say you have Wi-Fi in your home, right? So this Wi-Fi works at its best when the device is closest to the Wi-Fi, right? You can assume that as zero, maybe meters distance, right? And then as you move far away and start moving away from the Wi-Fi, your connections, your speed, everything starts to get decreased, right? So let's say there is some point beyond which the Wi-Fi isn't showing on the device that you're using, maybe your laptop or your desktop or mobile phone, etc. Right? So there will be some distance at which maybe let's assume 10 meters of distance, right? This is the maximum distance at which this Wi-Fi can provide, connections and help you browse through the internet, right? And beyond this, maybe at 10.5 meters of distance, this Wi-Fi is not working or it's not showing in your device, right? So here, basically, if we talk about this is nothing but range of Wi-Fi, right? Range of Wi-Fi. In the similar way, the criteria works, right? Whenever we talk about range, it's always between minimum and maximum values. The 0 meter distance in case of your Wi-Fi is the minimum distance, and this is the maximum distance at which your Wi-Fi catches signal, right? So this is the range for Wi-Fi. In the similar way, whenever we will be working with any continuous data, right? So continuous data is nothing but when real numbers are present, right? Real numbers are the numbers that you can represent on a number line, right? There are basically two types of data, the categorical data and the continuous data. Categorical data is when you're uh, any particular column has categories. For example, gender column has male and female categories, right? In the similar way, department column. This department column has, 5, 6 different type of departments. They are not numbers, right? At the same time, continuous data is basically real numbers. Let's say if we talk about salary, right? It's a continuous data. If we talk about age, right? It's a continuous data, right? At the same time, let's say if we talk about maybe hike column, right? Hike is also continuous data. All right. So your range is defined for continuous data only. You cannot define range for categorical data since they're not numbers, right? Hence, you won't have minimum and maximum values. All right. So this way, your range is defined. Now, when we talk about, let's say, a range of values, right? So always, let's say, if I talk about the same data set, just give me a moment. I'll clear out a few things, right? So I think I can remove this part. All right. So here, let's say whenever we talk about the organization, right? People are drawing salary within a range of values. This is minimum salary offered to any particular employee, and this is the maximum salary, right? So when we talk about the salary column here, right, we'll have minimum and maximum salaries. defined already, right? Now, the thing is, your percentiles, these percentiles works on continuous data only on continuous data, right? This only works on continuous data. It's not defined for categorical data. All right. Now, let's say if we dive back into the example that we were considering, right? So people who are working employees, let's say if you want to know where exactly in terms of salaries you stand in the organization, what could be done is you simply go to your HR, right? And simply ask for the percentile in which your salary falls, right? Or salary percentile, right? They'll come up with a number, maybe let's say 40th percentile, just an example, right? Maybe some person A, his salary falls at 40th percentile, right? 40th percentile. So this basically means this person A has more salary than 40% of the employees, right? This is more, and he has less salary than 60% of the employees, right? This is what this percentile tells you about, right? It tells you about the position, right? And this is purely in terms of when we are talking about the salary column, right? So in terms of salary, let's say if person A wants to know where exactly his salary falls or where exactly in terms of salaries he fall into the hierarchy of the organization, he can simply ask to an HR about what percentile his salary falls into. And again, HR will come up with a number, right? And let's say if this is 40th percentile, so this basically means this person A is earning more salary than 40% of the employees and is earning less salary than 60% of the employees, right? So this is how percentiles can be. Uh, you can understand percentiles in this way, right? This is again a piece of information that is given purely based on statistic. And what exactly is the statistic we are using? We are using the percentile statistic here. Right? Any kind of measurement is normally termed as statistic. Anything that you can represent as a number, right? Anything uh, you can represent as a number is a statistic. All right. So this is how you can understand the percentiles part, right? So you can simply raise your hands if you're able to understand this, right? If you're following along with the session, you can simply raise your hands. Anyone having doubts, you can of course ask the same in the chat section. All right. Now, to get into the technical parts, once you've understood what exactly is the intuition of calculating percentiles, all right. So, okay, why these terms? Because these are the technical terms, right? And this is how you can understand uh, percentiles here. All right. Okay. So let's take, let's say if the same example is for 90th percentile, right? This basically means, right, this employee, or maybe let's say again, employee A, he's earning more salary than 90% of the employees, right? 90% of the employees. And he's earning less salary than 10% of the employees, right? So this is how you can understand the percentiles. All right. Now, moving on, if we try to understand this with technical perspective, right? So technical, with respect to technical perspective here, right? How percentiles are defined is, let's say, like uni means 1, bi means 2, right? Tri means 3. In the similar way, if we go on increasing this, percent basically means 100, right? Percent basically means 100. And this percentile term has came into existence right? So basically, percent means 100, right? And percentile at the root basically means when you divide any data set, into 100 parts or 100 equal parts, right? If we divide into 100 equal parts, right? This will be, this is basically the idea behind percentile, right? And it could be a scenario where you're dividing the data into 100 parts, but they are not equal, 100 non-equal parts, right? So dividing your data set into 100 equal parts, this is basically percentage, right? And when you're dividing your data set into 100 unequal parts, this is percentile, right? And percentile tells you about the position. It does not tell you about the exact figure or exact quantity, right? For example, let's say someone salary standing at 80th percentile, right? Someone's salary standing at 80th percentile. This basically only gives us an idea of the hierarchy, right? Whether he is drawing more salary than 80% of the employees and less salary than 20% of the employees. It does not tell you exactly the salary figure, right? At the same time, let's say if someone says that 80% of my salary goes into rent, right? This basically we can come up to a quantity here, right? Because 80% of salary. So this is nothing but 0.8 fraction of the complete salary, right? So let's say if the salary is 10,000, right? If the salary is 10,000, so 80% of these, if someone says that 80% of the salary goes into paying rent, this basically means 0.8 parts of the salary goes into paying rent. All right, so this is nothing but 0.8 into 100. Sorry, this is 10,000, right? So this is nothing but this will be 8,000, right? So we can come up with a figure, and this is nothing but this is a quantity, right? In percentiles, we do not get any quantity as the output. It only tells you about the relative position, right? It only tells you about the relative position. All right. So here, when you're dividing your data set into 100 equal parts, this is percentage. And when you're dividing your data set into 100 unequal parts, this is percentile here, right? So yes, this is the basic difference between percentage and percentiles, right? And when you divide your data set into different number of parts, the term changes, right? In the similar way, like we'll be discussing about quartiles, right? And quartiles is when you divide your data set into 4 parts. You divide data into 4 parts and 4 unequal parts. All right. So yes, this is how we can understand this. All right, so let's see a practical example. This will give you more clarity on this. All right. Now, let's say we'll be using the same data, right? We were using previously the employee data set, right? And this employee data set, let's calculate a few outputs on the annual salary column. All right. Now, to calculate the percentiles, we directly have the percentile formula, right? And there are basically two forms of percentiles that can be calculated, right? First is inclusive and second is exclusive, right? So in inclusive, like how I've told you, a range is always defined between minimum and maximum values, right? This is between minimum and maximum values. All right. So these minimum and maximum values are included in inclusive. Right? These are included in inclusive, but they are not included in exclusive. Right? These are the two forms of percentiles we can calculate. And for that matter, any any statistic that can be calculated on the any statistic that can be calculated on your data, right, basically has two forms, right? First is done for the population, right? And second is for a subset, right? A subset is also called as sample, right? So everything in your, whenever you'll be working with, any data set, the complete data set can be considered as either a population or a sample, right? If you consider it as a population, there are basically uh, two things, or there are a few things, a few restrictions, right? The first thing is if you consider a data set as population, no more data can be added to this, right? No more data can be added, right? And this is considered as the final data, right? So for example, let's say if I uh, treat the data set I'm dealing as of now, which is the employee data set, if I treat this data set as a population, right? So what will happen is no more data can be added. This basically means no employee is going to join, or no new employee is going to join the organization, and none of the existing employees is going to leave the organization thereafter, right? So which will, of course, which is not the case, right? Because employees, they join and resign on regular basis, uh, to and fro from any organization, right? So this basically, uh, this could be one of the reasons why if you use your data set as population, there will be these restrictions, and based on these restrictions, the mathematical formula that is used to calculate the same statistic, right? The same statistic, percentile in this case, right? Percentile in this case, if you treat your data as complete population or sample, right? Okay, so let's start with the population here. If you treat your data set as population, right? So the formula for population and samples are different, right? Which is why we always consider our data set as a sample, right? A sample is basically a subset of population itself, right? This is nothing but this is the subset of population. And when I talk about the subset, this subset could be, let's take an example, right? Let's say I have 1, 2, 3, 4, 5. This is my complete data, right? This is my complete data that is available, right? I can draw various subsets out of this. Let's say I'll pick only one element, let's say 1, or I can pick only one element 2, right? Like this, any individual element can be picked up. The second combination could be, let's say I can take pair of two elements, maybe 1 and 2, right? Or 1 and 3, or 1 or 4, right? Or let's say 2 and 5, any two of it, right? In the similar way, I can take any three of it, let's say 1, 2, and 3, right? Or maybe 3, 4, and 5, maybe 2, 3, and 5, like this, any three. right? In the similar way, I can take any four values, maybe 1, 2, 3, 4, right? Maybe 2, 3, 4, 5, right? This way. Or I can take all of these as one, as a subset. 1, 2, 3, 4, and 5. Right? So this is also a subset. The complete data that you have in your data set can be considered as a sample of that particular data only, right? So you can raise your hands if you understood this part, right? How subset can be considered, or a sample from the complete population can be considered even after taking the complete data. All right, great. So yes, this is how uh, the difference between samples and population is generated, right? And every time you're going to use the sample, or you're going to consider your data as a sample. All right. So those who are asking for repetition, surely not a problem. You just have to understand one thing, that from this data set here, right? From this data set here, 1, 2, 3, 4, 5. Let's say we have 5 elements, right? If I talk about taking a subset of this, subset is just any number of values less than or equal to the total number of elements. We have 5 elements here. You can pick any number of elements which is less than equal to the total number of elements. In this case, we have 5, right? So as I've told you in OR part, when we were discussing this OR here, right? I told you that either less than will work at a time or equal to will work in less than or equal to, right? So when equal to works, right, your total number of elements are consumed and they are taken as a subset here, right? So this is how your data is considered as a sample, and the formulas for sample and population are different for every statistic that you're going to learn from now, right? And this population and samples, right? Population and samples, these are two very important terms wherever you're dealing with the data. Right? So I hope now you're able to clarify this difference here, the difference that we have between population and sample, right? So like we have population and sample difference, right? In the similar way, when we talk about percentiles, these in percentiles, when these are included and not included, and what is included and not included, the minimum and maximum values, right? Minimum and maximum values in your data, if these two values are included, it's the inclusive form of percentile, and when they're not included, they're exclusive form of percentiles, right? So this is how two percentile values you will get whenever you calculate percentile at any given figure, right? And just to tell you that any any tool that you're going to use, be it let's say Excel. Okay, in Excel, we have options for inclusive and exclusive, right? But all other tools like SQL, right, or Python, or any module like NumPy, right, that you're going to study in future, right? All of these, they basically have the functions defined, and this is the inclusive formula they're using behind the scenes to give you the output of percentiles, right? Percentiles can be calculated everywhere, be it Excel, SQL, Python, NumPy, or let's say SciPy, or stats model. We are going to learn about these modules in the coming times, right? Majorly when your Python session begins, all of these are just added modules of Python, right? So they treat your data on talking only of percentiles. They treat your data as and give you the inclusive part of the output, right? We'll see this practically on the data set, and you'll be able to establish this difference very clearly, right? So let's move ahead and execute or calculate the percentiles on the salary column, right? So that we can get this idea, and let's talk about this now. right? So here, yeah, all right. So here, what we'll do is like how percentages can be calculated on every figure or uh, at every value. For example, 1%, 1%, 2%, 3%, 3.5%, and so on, right? In the similar way, percentiles can also be calculated. And since percent itself means 100, right? So which is why percentage and percentiles, both of them will be calculated only from 1 to 100, right? Or it's better to say 0 to 100. The 0, since it does not face any, any extra impact on the output, hence we start from 1 mostly. All right. Now here, we'll calculate percentiles. First will be for inclusive, right? And second will be for exclusive, right? So these are the two formulas what we are going to use, and these will be the percentile values, right? And percentile values is nothing but, let's say, these values 1, 2, 3, and so on. We'll see what exactly is the figure we are getting, right? We'll go up till 100. Right, so we'll go up till 100. We'll calculate the percentiles here. Yeah. So here, let's see the inclusive formula, right? We directly have this percentile dot inc. This is the inclusive. It clearly says it returns you the kth percentile of values in a given range, right? Where k will range from 0 to 1, right? But here we have values from 1 to 100, as we already know, right? So these values can easily be converted into fractions between 0 to 1. And how this will be done is will be simply dividing this with the minimum value here. All right. Let me show you how scaling of data is done. Let's insert one more value here, which will be 0. All right. So let's start with the 0th value, right? So we have this percentile. Okay. So I was to give you. Oh, okay. So here, what is done is, let's say if you want to scale any given set of values, right? So let's talk about scaling a little, right? Or scaling of data is done. This is one of the most important step in machine learning, right? You'll learn more about this in machine learning. I'll just give you a basic idea, right? The simplest form of scaling that we do, that we usually do, right, is since my data is equally divided. These values are equally divided, right? If you calculate the difference of 1 and 0, it is 1. Between 1 and 2, this is 1. Between 2 and 3, this is 1. Between 3 and 4, this is 1. 4 and 5, this is 1. And so on, right? So the difference is 1, which means that the data is equally divided, right? Values from 0 to 100. Right? The values from 0 to 100, they are equally divided. They're equally divided into 100 parts. I hope this everyone is able to establish this difference here, right? Everyone is able to understand how values from 0 to 100 are equally divided because the difference between every subsequent value is same, right? It basically means you start from 0 and go on adding 1 every in every consecutive step, and you'll be able to get this, or you'll be able to generate this data, right? 4, 5, 6, and so on, right? You can simply raise your hands if you're able to understand this particular statement that the values are equally divided in 100 equal parts. All right. So here, since the data is equally divided, so for these kind of data sets, there is something called as the z-score kind of scaling, right? This is also in machine learning. This technique is termed as min-max scaling, right? Min-max scaling. This basically means, let's say if I want to divide or if I want to convert these values into fractions, right? And fractions are always from 0 to 1, right? You basically fractions of 0 to 1. All right. So what I'll do is I'll pick any value. Let's say there's some value x, right? So this data will have some minimum value, right? It will have some maximum value, right? So the minimum value in our data set starting from 0 to 100, right? So 0 is the minimum value here, all right? And the maximum value, if we talk about, is 100, right? So this is the range of data, and that this is how range is defined, right? So once the range is defined, we have minimum and maximum values, right? So once we have minimum and maximum value, for any value in this range of values from 0 to 100, if you want to convert that value into the fraction between 0 and 1, this is usually done like this. Let's say x is the value. So you'll simply subtract x from x minimum, right? Divided by x maximum minus x minimum, right? I can understand this formula looks a little complex, but it is very easy to understand, right? Let's take any example and apply this. Let's say if x is 2, right? So I want to scale this value between 0 to 1. All right. So what I'll do is I'll take 2 x minus x min is the minimum value in this range, which is 0, divided by the maximum value. X max is the maximum value, which is 100, right? This value, and minus the minimum value, which is again 0. So this is nothing but 2 by 100, right? And this will turn out to be 0.02. Right? In the similar way, if you want to convert any other value, right? Let's take x as, let's take x as maybe 35, right? So what I'll do is I'll simply apply this 35 minus 0 by 100 minus 0, right? This is nothing but 35 by 100, and 35 by 100 is nothing but 0.35, right? So since you can see this pattern here, since the minimum value itself is 0, right? So we are basically dividing the given number, right? Given number x by 100, right? Because subtracting 0 from any number will not make or will not put any uh, impact, right? Which is why if you mention this or not, it hardly matters, right? So which is why here you can see every value, what we are doing is, since x minimum itself is 0, x minimum itself is 0, so basically this form further gets converted into x divided by 100, or let's say x divided by x min, right? And x divided by x max, and x max is 100, right? So you can simply divide every value by 100 to convert it into fraction between 0 to 1. Right? So I hope you're able to understand how the scaling is done, right? And this is min-max scaling, usually called as normalization in data science terms, right? Or data science lingo. This is called normalization of data. You can apply this technique to any given data, and your data will be converted between the range of 0 to 1. Right? So yes, you can simply raise your hands to confirm this if you're able to understand the scaling part, right? How data will be scaled. All right. So having understood this, right? Having understood this, we are defining the values of percentiles from 0 to 100, right? But in the formula of Excel, right, it's clearly mentioned that the k that you're going to uh, pass as input, this should be in the range of 0 to 1, right? this should be in the range of 0 to 1, which means the kth percentile. Whenever we talk about k in percentiles, this is the kth value. Let's say if you want to calculate 35th percentile, so k holds the value of 35, right? But here, my k holds the value of 35, but the formula in Excel accepts only the value of k between the range of 0 to 1. All right. So here, what I'll do is I'll normalize this data first, right? So this will be 35 minus x minimum, which is 0, divided by x maximum is 100, minus x minimum is 0, right? So we are basically dividing 35 by 100, which is 0.35, right? And now this 0.35 can be passed as the value of k as input in the formula for percentiles, right? So we are going to apply this operation every time we are going to use the formula of percentiles in Excel. All right, so why data scaling is important? Data scaling is basically important because, again, I'm going to, in machine learning, what happens is whenever a machine learning model is trained, right? So machine being let's say, being a machine, right? So basically, as low as the variance of the data is, the better machine learning model will be trained, right? Variance is nothing, but we are going to discuss this term in maybe next session, right? When we'll discuss about moments, right? So this variance of machine learning algorithm should be low, right? And variance basically means how much spread your data has. All right. So to reduce the spread of the data, here, let's say if we talk about if original values were present between 0 to 100, right? So basically my values are spread between 0 to 100. But when I scale this data between 0 to 1, apply normalization to this, right? So these values will be converted between the range of 0 to 1, right? So the spread of the data now is between 0 to 1. All right. And hence the variance reduces, which is a very, which will put a very good impact on the machine learning algorithm, right? And my algorithm will be able to identify this pattern very quickly and will be trained. It will train a better machine learning model than unscaled data, right? So which is why scaling is important here. All right. So don't worry, any data set that you're dealing with, right? You'll not use this data as it is. There is a lot of pre-processing, right? There are a lot of pre-processing that is done on the data before it's passed to machine learning algorithm as input. Right? Okay, so one of you here is asking, what about data type? If we change from numeric to string or character, are we going to follow the same formula? I've already informed. Percentiles are only defined for, these are only defined for continuous data, right? If the data is categorical, even if you encode this data, right? This is again a technical term here. Encoding of data basically means representing any category in the form of a number, right? So maybe let's say if you have female and male, I'll assign female with the value of numbers, but again, these are only categories, hence you cannot apply any mathematical operation on this. If I ask you to calculate the average, can you calculate the average of male and female? You cannot do that, right? So even after converting this into numerical representations, they remain categories only. You cannot come up with, let's say 0.5 is the average. This is wrong because conceptually this is wrong, right? Something that you cannot do with characters, even after you encode that, you will not be able to do that. All right, so you can understand this like this. For example, let's say if some person, let's say some person named Aman, right? There's some person, let's say his name is Aman. Yeah. So his name is Aman, right? And let's assume that this person does not know how to drive a vehicle, right? He does not know how to drive a vehicle. Let's say, right? He does not know how to drive a vehicle. Let's say what I'll do is I'll change the name of this person from Aman to maybe Ajit, right? Does this mean that this person will automatically learn how to drive? right? Of course, no, right? Because this is something that is a skill, right? In the similar way, statistics, let's say complete statistics, is defined separately for categorical data and continuous data. Categorical data and continuous data, right? If your data is continuous, then a certain series of statistics can be calculated. If your data is categorical, a certain series of other statistics can be calculated, right? One of the best examples of this is mode, right? Mode can be calculated on both continuous and categorical values, but it's only reasonable to calculate for categorical data. It's not reasonable to calculate this for continuous data. It will not give you any output or any information about the data, right? We'll discuss mode as well in next session. All right, so this is how you can understand something that is defined for continuous data cannot be used on categorical data, even after you encode the data or change how it looks like, right? All right, so the percentiles, just to give you this idea, the percentiles that we are discussing, right, is purely defined for continuous data. It's not defined for categorical data. If you go on calculating percentiles, you'll receive error, right? You cannot calculate percentiles on categorical data. All right, so moving ahead with this, having understood how scaling of data is applied, we'll apply the scaling on this data to calculate the percentiles. Let's get moving with the inclusive formula of percentiles here, right? It returns the kth percentile of values in any given range, right? Where k will be in the range of 0 to 1, right? So moving ahead with this, I have to pass an array. Array is nothing but a series of data on which you want to calculate percentiles, right? So let's pick the salary column, and my salary column is present in this functions sheet here. This is my complete salary column that I'm selecting. All right. Having selected this, I'll have to pass the value of k. All right. So here, just look into the formula bar. If you're not able to, see the formula, I'll go back to my percentile sheet here, right, and remove this percentile. And I'll take this value, right? I'm taking the reference cell because I want to use the feature of flash fill here, right? So to calculate 0th percentile, I'll simply pick the value of 0, divide this by 100, right? This will scale the data, right? This will scale the data, and I'll close this bracket. And this is inclusive. This basically means we are getting a value here, right? And this is the 0th percentile value. If we, let's say, try to, break this down, what information this is giving us, according to the definition that we have learned for percentiles, for any given nth percentile, right? It is not telling us about which employee draws this salary. It's only giving us the value of 0th percentile, right? So let's say if we talk about 0th percentile, right? Let's say this person is A, right? And this A is earning more than 0% of employees, right? And is earning less than 100% of employees, right? This is according to the definition, right? So if try to understand this logically, if someone is earning more than 0% of employees and it's earning less than 100% of the employees, this basically means that this is nothing but the minimum value in my salary column, right? If I think logically, this is nothing but the minimum value in my salary column, because there is no value which is less than the minimum value, right? And this is exactly what this particular piece of statement says, right? Or this statement, they're equally, valid. That this person whose salary is 40,063, right? He's earning more than 0% of the employees, and 0% of any figure is 0 only, right? And he's earning less than 100% of the employees. Let's say if the total count of employees, let's assume we have 1000 number of records, right? So 0%, 0 by 100 into 1000, right? So 0 multiplied by any number is 0. So 0 into 10 is 0, right? So this is basically the minimum value in the data. Right? I hope everyone is able to follow this part, how this is the minimum value, or 0th percentile is the minimum value in the data. You can simply raise your hands, right, to confirm this, or you can simply drop your doubt in the chat section if you have any confusion. All right. Now, in the similar way, if I talk about the 100th percentile, right? If I talk about 100th percentile and go according to the definition again, let's say I get some value, maybe a 7-digit figure, right? And this 7-digit figure is the value of 100th percentile. Again, if I go according to the definition, and let's say this person B is earning this value, all right? So here, this B is earning no more than 100% of the employees and less than 0% of the employees. Right? So if he's earning more than 100% of the employees, right? And let's say we have 1000 records, 100%, 100 by 100 into 1000, right? This is the total 100% of 1000. So this is 1000. This basically means he's earning more than 1000 number of employees, and this is exactly the total number of employees itself, right? Inclusive of himself, right? So B is included here in 1000. So he's earning more than 100% of the employees, right? So this becomes the maximum value in the data. All right, so this is how you can deduce this, and this is how percentiles, they are related to, it will give you a lot of additional information as well, right? So let's talk about the next percentile value, the value at first percentile. All right, so how to less than 0%? So basically, you cannot calculate anything less than 0%, right? Percentage does not work that way. It's defined only for between 0 and 100, right? Even something called as 150% is mathematically wrong, right? Percentages are defined up till 100 only. If you double the value, it's 100% on top of 100%. Right? Now, let's move ahead and see the next value. I'll simply drag and drop. I'll show you the formula here. You can check the same in the formula bar, right? This is the formula that we are using. You can simply, have a look at this formula bar, which formula is basically used, right? Or what is the formula that we are using. Anything that you see here like this followed by an exclamation mark, right? This is the name of the sheet. Let's say functions exclamation K basically means this is in the functions sheet and a K column, right? This has to be read like this, right? If you want, you can manually type this as well. There's absolutely no issues, right? And this is percentiles A5, right? So this is the percentile sheet that we are currently working on. And here it is taking A5, this is the value A5, right? And then after taking this value, it's dividing it by 100, right? So this is basically the value of K that we are passing. This is the value of K that we are passing here, right? And this is nothing but 0.01. You can manually also do that here. Let's say I'll simply use percentile.inc. In arrays, I'll simply use the functions sheet here, right? And in that, I'll use K column, right? Followed by the percentiles sheet, right? Percentiles exclamation followed by, let's say, A5, right? So this is A5 divided by 100. You can write like this. Also, you'll get the exact same value, right? Otherwise, if you want to put this manually, remove this, right? Simply put 0.01 and you'll again get the same value. Right? So this is basically mathematical calculation taking place behind the scenes, right? And in machine learning, these kind of calculations will be carried out at a very larger level, right? Where you'll not be able to see what exactly what exact calculations are going on. Everything will give you a number as an output, right? So you have to understand that number. So to understand that particular number, you should know the concept, right? And this is how the concept is defined, right? So this is the value at first percentile, right? And since this is the value at first percentile, so there are basically 1% of employees, right, whose salary lies less than this, which is $41,727 annually, right? There are 1% employees, right? And this could be this one person could be 1% of the employee, right? Because the data is not equally divided in the salary column, right? The data is not equally divided, which means the difference between every two salary figures is not same. Someone is earning 40,063, maybe some other person will be earning 40,064, right? The salaries are different, right? The values are different, and these values are not equally different. Let's say some other person will be earning $41,000, right? So the difference here between 40,063, and a better idea on this, what could be done is I'll sort this by the salary column, right? Let's say sort smallest to largest, right? And here, what I'll do, I'll insert a column here, right? And in this column, what could be done is I'll simply subtract every subsequent value. Let's say this minus the value above this, right? And you see, this is the difference between salaries, which is not same, right? These two values are not same. The difference between salaries of two employees, right? With the minimum difference in salary, this difference is not same, right? Which is why this data is not equally divided into 100 parts, right? Percentiles will help you to establish the values, all right? And this is always not necessary that any value that you're getting at a particular percentile will exist in the salary column. For example, let's say 41,727. This is not a certainty that this value will be present in the salary column, right? So let's check 41,727.45, right? So this is the closest value that we have, 41,728, right? And these values in between, we do not have these values, right? In percentile, right? We don't have this value. Any value that you'll be getting after this will be greater than this value, right? Every value that you're going to calculate will be greater than the previous value of percentile, right? And this is how you can simply calculate percentiles for the complete salary column, and your values will gradually increase moving from 0 to 100th percentile, right? And this is the maximum value in the data. And this is the maximum salary figure someone is drawing. Right, so this is how percentiles can be calculated. Talking about the exclusive part. In exclusive, the formula is a little different, right? Formula.exe, it says same definition, right? Returns the kth value, kth percentile of value in a range, right? Where k will be in the range of 0 to 1, and exclusive, which means 0th and 100th percentile will not be part of the data, right? So let's say I'll simply select the same column again, which is my salary column, followed by, I'll divide this value by 100, right? So it will give me a number error. This is giving me a number error because it's not defined for the minimum value, right? Exclusive itself means that the minimum and maximum values are not included, right? Which is why you face this number error at 0th and 100th percentile, because it's not defined for it, right? So if we go on calculating, you'll get the values from first percentile, right? And you'll see at 100th percentile as well, we are getting the same number error, right? Because this is not defined for maximum value, right? Hence inclusive and exclusive. All right. Now, in the similar way, like we have this, right? In the similar way, when you divide your complete data set into 4 parts, it will be quartiles, right? This will be quartiles when you divide your data set into 4 equal parts. All right, so this is how it is defined. And let's use the quartiles here. All right, so exclusive and inclusive and exclusive, it is defined for both of it. And we'll copy the same numbers again. All right, so let's not copy, let's directly calculate, right? So since when you'll be dividing your data into 4 parts, right? When you divide your data set into 4 parts, let's say I'll divide this data into 4 parts, right? So each of this part, like how we have between 100 parts, right? This is percentile, and this percentile is from 0, 1, 2, and so on up till 100. Right now, here, when you divide your data into 4 parts, it will be 0, 1, 2, 3, and 4. Right. So here, let's say this is your first part, this is your second part, this is your third part, and this is your fourth part. All right. Okay. I see one of you asking if both of them have same formula, why values are different. Here, a little mathematics is involved, right? You need to have a basic understanding of mathematics. Let's say, let's assume there's a number called 100, right? Let's say we have this number. Now, you tell me if I divide this number by, let's say, 5, and I divide the same number, will have higher value as output. Is it, let's say, this V1 or V2? You can mention the same in the chat section, whether this V1 value will be higher than V2 or this V2 value will be higher than V1. You can mention your answer in the chat section. Which value will be higher? Is it V1 or V2? All right. So for majority of answers, we are getting this, that V1 will be higher than V2. Those who have mentioned this, you are correct, right? So the same principle works here in percentiles, right? Let's say we have the record of 1000 employees, right? And here in inclusive, right? In inclusive, all 1000 employees records are used, right? Because minimum and maximum values are included, right? Minimum is one value, maximum is also one value, right? And both of them are included. But in exclusive, there are only 998 values involved because minimum and maximum values are excluded from this data. It's not used in the calculations, right? It's not used in the calculations, which is why when you divide it by a higher number, right? When you divide it by a higher number, you are expected to get the lower value as the output, right? And when you're dividing this by a lower number, you're expected to get a higher value as the output, right? So here what happens is in percentiles, there are a few, there's a few pattern that you will notice, right? And the pattern is if you calculate the difference between exclusive and inclusive, these differences, right? You'll find one pattern that this value in exclusive is a little less than inclusive, even after we are having the total number of elements very less in exclusive, right? This difference, or let's say the value of exclusive is less, right? But I told you that in exclusive, 998 numbers are used, right? And since when you divide this by a smaller number, you're expected to get a higher number as the output, right? But here is a catch, and the catch is of median, right? Median is nothing, but this is the middle value of your data, middle value of the data. You'll see that this difference will go on decreasing, decreasing, decreasing. It will have up till 49th percentile, right? At 50th percentile, both of these values are exactly same, which means inclusive value is equals to exclusive value, right? Because this is the middle value of your data, or it's better to say middle value of your sorted data. Data is sorted from, let's say, in ascending order, right? And if you calculate the median, this is the middle value of your data, right? And middle value will always be same, right? Middle value has to be at the middle of the data, right? And this middle value, you'll see this, we show you, right? We are coming to median only. You'll see that at 50th percentile, the values are exactly same. The values are exactly same at 50th percentile, right? The values are negative, or it's the difference between exclusive and inclusive is negative if you go above 50th percentile. If you go in this direction, the difference is negative. If you go in this direction, the difference is positive, right? You'll see this pattern. Let me show you, right? Let me insert a column here that will say that this is the difference, right? This will be, say, the difference here, and the difference will be between, let's say, exclusive minus inclusive, right? Exclusive minus inclusive, which means this value minus, right? Let's say this value minus the value of inclusive, right? It will throw a number error because we are trying to subtract not a number with number. All right. Now, if I go on, dragging this, you see negative values we are getting, which means exclusive value is higher than inclusive value, right? And if we go on doing this for every value of percentile, you'll see all these values are negative, and this negative difference will be up till 50th percentile, where the value holds, or both of them holds equal value, and the difference is exactly zero. Now, what happens is beyond this, moving 51 onwards, we are getting this positive difference, right? We are getting this positive difference here, right? And you'll find this pattern almost in every data you'll be dealing with, right? Because the differences are not uniquely, they're not, the same value of difference, right? These two, none of the two values are exactly same. None of the two values are exactly same, right? Which means the difference is not same. And since the difference is not same, you'll get this kind of pattern in your data, right? So this is exactly why we are getting this value as the output. and the differences in the values. Right, so yes, percentile. All right, so why this value show in minus? Because we are subtracting a lower number from a higher number, right? And this is how mathematics work. Let's say if you subtract, let's say, if you subtract 10 minus 5, you'll get a positive 5, right? But if you subtract 10 minus 15, you'll get a negative 5, right? This is because we are subtracting a lower number from a higher number, or we are subtracting a higher number from a lower number, right? And here we are subtracting a lower number from a higher number, which is why you're getting a positive value here, right? And this is the basic mathematics, right? Basics, right? This is why we are getting this negative value, because this value is smaller than the inclusive value. All right. Now, moving on, when we have divided our data set into 4 equal parts, here the parts are, right? If we talk about the quartiles here, in quartiles, we are dividing between 4 parts, right? These are called first quartile, referred as Q1, second quartile, referred as Q2, third quartile, referred as Q3, right? So, and you can say this is the fourth quartile, referred as Q4. Right, so these quartiles are nothing but range of values 0 to 25, right? 25 to 50, 50 to 75, and 75 to 100. Right, this is the general representation. Usually when we talk about these quartiles, right? So they contain a set of values, right? And quartiles are nothing, just an extension of percentiles. When in percentiles, we are dividing into 100 equal parts, 100 parts, right? In quartiles, we are dividing into 4 parts, right? And these are the first quartile value, right? This is nothing but this is 25th percentile, right? Second quartile value is nothing but 50th percentile. Then we have third quartile value, which is 75th percentile. Right? Then we have Q4 as well, but we don't usually use that because that will be the 100th percentile, which is nothing but the maximum value, right? So this is how quartiles are defined. Small q defines the percentile value, and capital Q refers to the set of values or range of values, right? So this is how quartiles are defined. And since quartiles are defined only at certain percentiles, which is why you'll not get every value here. You'll only get at 0th percentile, you'll get at 25th percentile, 50th percentile, 75th percentile, and 100th percentile. These are the only 5 values that you'll get in quartiles. All right. So this is how quartiles work. Let's calculate the quartiles using Excel formula, right? So let's use the inclusive part. All right, and here also quartiles have direct functions called quartile.inc, right? This returns the quartile of the data set based on percentile values from 0 to 1, right? And this is inclusive. Let's use the inclusive part. Again, we have to mention array, which will be the salary column again. I'll go back to my functions sheet and select the salary column, followed by a comma, go back to my percentile sheet here, and I'll simply take the value of quart, right? And if you see here, it says that the value of quart has to be either 0, 1, 2, 3, or 4. You cannot pass any other value, right? Because quartiles are again divided into 4 parts only, right? So I'll simply pass 0 for minimum value, right? So I'll simply close this bracket, and I see that we are getting the minimum value here. Right? Same goes with exclusive. In exclusive, minimum and maximum values are excluded, right? Which is why in quartile formula here, you'll see that, let me pass this manually, right? This is functions, K column, followed by the quartile value, and you'll have only three quartile values, 0, 1, and 2. If I pass 0, sorry, 1, 2, and 3. Excuse me, right? So if we pass 0 as the value, we'll get number error, right? How we got for percentiles. All right. Now, the next value that is defined is for 25th percentile. Let's go back here. This is my 25th percentile. All right. So here we'll calculate for quartiles, and I'll use again the quartile formula dot inc. Array will be again my salary column, right? My salary column, which is K, followed by the value of percentile, the value of quartile, right? So the first quartile, I have to pass the value as 1, which will be 25th percentile. Pass the value as 1, close the bracket, and see the output. These two values are again exactly equal because quartiles are derived from percentiles only, right? Just an extended form of it. Same goes with the quartile.exe function, with, let's say, in from functions sheet, will take kth column, which is the salary column, value equals to the 25th percentile value for exclusive, right? Next comes is the median value. Right, next comes is the median value at 50th percentile. And 50th percentile, again, we can use, let's say, the quartile.inc. Array will be from my functions sheet, and this will be kth column, right? And followed by 2, which is the 50th percentile or the median value, right? And again, the values will be, of course, same without a doubt, right? So again, functions sheet, kth column, and the value of median as 2, right? And followed by, again, 75th and 100th percentile will have again the same format of values. Right, so I hope everyone is able to understand this. You can simply, raise your hands to confirm so that we can. Okay, those who are mentioning no, you're advised to mention exactly what you did not understand. Right, and for others, if you're able to understand, you can drop a yes in the chat section or raise your hands. Right, so guys, just to mention, I've already said these are all part of practice, right? The more you practice, the better you'll be able to understand, right? This is not something that you will watch and expect that you'll be able to understand this. Until and unless you practice, this will be a little hard to understand by going this way. Right, so it's always advised to go through the recorded session more than once. Right, so why exclusive? Why there is no value? Because that is how the exclusive concept is defined. Right, that's how the exclusive concept is defined. The minimum and maximum values are not to be taken if you're going the exclusive way. Right, so that's how it's defined, right? You could let me know the other doubts. This is exactly why we are getting this error. All right, so guys, I've already provided this data set on the GitHub link. I hope everyone has that, right? You can drop a Y for a yes if you already have the GitHub link, right? I've shared this at least, 2 times in every session. All right, so the concept of percentiles here will basically help you to understand the data in a better way, right? This is the statistical analysis that you'll be performing to understand your data. And this is the root of data analysis that we are learning, right? This is the root of data analysis why we are learning. And you have to understand this because, let's say, these are some concepts that will be used every now and then when you'll be dealing with the data sets. All right. So, yes, this is how it is to be. Yeah. So, just give me a moment. I'll quickly complete this. Right. So, yes, these are the respective outputs that we are getting. So can we use only one percentile? You cannot do that. Let's say, assume you're going to school and your school, school says that every student will be offered with the same percentage value, right? So that does not make sense unless you have variability. There's basically no need of calculating, right? So for example, let's say, I'll give you the example, right? So let's say I have this value 1 appearing every single time for 50 number of times. If you calculate any percentile, right, a continuous data, right? This can be considered as a categorical data because one is repeating every single time, right? You learn this how to identify whether to treat your data as continuous or categorical. I can represent one on a number line, but still I cannot categorize this as the continuous data, right? Because there is basically no variation, right? There's no spread on this data, which means this data is of no use, right? What can you generalize, or what information does this series of data gives you? Absolutely nothing, right? Right. So yes, this is how quartiles and percentiles are defined. I'll give you a few more functions that you can use, right? Just an extension of this. For example, to find the minimum value, we have the min function, right? Min function gives you the smallest value in the data, right? You simply pass the functions sheet, the k value here, right? It will give you the minimum value of the salary column, right? In the similar way, we have maximum value as well. Let's say if you want to calculate using the maximum value directly, simply use the max function, right? It returns the largest value. And again, I can pass the functions, right? Kth column. Close this bracket, and this is the maximum value in the salary column, right? Now, moving on, like we have minimum and maximum functions, right? So any ready-made formula for percentile, this is the ready-made formula itself, right? If you go on calculating percentiles using, a mathematical formula, you're of course going to commit an error, right? The formulas are directly defined. You can check the same in the formulas tab, right? Simply click on this formulas tab here. You'll see various, right? Various types of formulas. We'll simply go to the statistical formulas, and you'll see we have uh, these percentiles defined, right? Percentile.inc and percentile.exe, right? And then in the similar way, we have quartile.exe and inc. These are the formulas that we are using, right? And they are the inbuilt formula only, right? These are inbuilt formulas for percentiles, right? Values you have to provide, this is the minimum amount of effort you can do to provide value, right? For example, let's say if you want to add values, you have to provide values first so that it can be added. You can use the sum function, right? But you have to at least make an effort to provide the input, right? In the similar way, any function that you want to use, you have to pass the input, then only you'll get the output. All right. Now, as we have the minimum and maximum functions to get the minimum and maximum values, in the similar way, we have large and small functions. This will give you any kth largest value. For example, let's say, if I ask you, what is the fifth largest value in the salary column, right? How will you get this? Right? If you go through the traditional, I have to pick the fifth value, right? It's a long procedure. We directly have a function for it. Simply use the large function. Large function returns the kth largest value in the data, right? For example, it's a fifth largest value, right? So you can simply pass the array. Array is again the data on which you want to find the nth largest value, right? So let's say the salary column again, I'll simply pass from the functions sheet, I'll pass this reference, right? And the value of k. So the value of k is basically which largest value, since I want the fifth largest value, I'll pass the value of 5, the value of k as 5. If I wanted maybe 10th largest value, I'll pass the value of k as 10, right? So let's say passing this is the fifth largest value, right? So this is where the large function comes into picture. In the similar way, let's say if I want the second largest value, right? Second largest value, I can simply use the large function again with the value of k as 2, right? So I'll simply use functions here, use k, and the value of k will be 2, right? So this is the second largest value, right? If I talk about the first largest value, it will be the maximum value, of course, right? Without an iota of doubt, that will be the maximum value in the data. First largest, simply use the large function again with functions taking the kth column here, right? And 1 as the value of k will get first largest value. This is the maximum value in your data. This is the maximum value, right? In the similar way, we can use the let's say nth largest value, right? Like how we are using the large function, in the similar way, we can use the small function for nth smallest value, right? And this nth smallest value can easily be calculated using the small function. Right, so let's say first smallest value, first smallest, right? First smallest is nothing but the minimum value. You can directly use the small function, right? Again, pass the array as input, which is the series of data that you want to pass in, right? So functions, okay. So this is kth column and 1 as the smallest value. I'll get the minimum value here, right? This is my minimum value in the data, right? Talking about, let's say, the second smallest, right? Again, use the small function here with the kth value, right? And the value of k as 2. Close this bracket. This is the second smallest value. If we see, right, this is 40,124. This is the second smallest value. And if we see on my percentile sheet here, 40,124 is the exact value that we are getting, right? In the similar way, 10th smallest, you can again use the small function. Right, so this is how you can use these values. All right, now comes the median part. All right. So median, as I've already told you, is the middle value in the sorted data, right? And median is basically a very important part of central tendency, right? So in central tendency, the first thing that you're going to understand after you get the data is you calculate the central tendencies, right? Central tendency, right? So central tendency is basically uh, something that can give you a little idea about the data you're working on, right? And a few values that can give you the idea of the data is, first is the average. I hope everyone knows how average is calculated and what kind of information it provides, right? Average, this is in technical terms, this is termed as mean of the data, right? This is the mean of the data, and the formula, and it's basically represented using mu, right? This is called mu. It's a just a representation, right? The second part in the central tendency, this is one part. The second part in central tendency is I want to know about the middle value in the data, right? I want to know the middle value so that I can, relate how far the minimum value is from the middle value and how far the maximum value is from the middle value, right? This will tell me about how wide my data is spread, right? So this middle value is termed as the median of the data, right? Then I also wanted to know how many times a particular figure is repeating itself in my complete column, right? How many times, right? So basically frequency, how many times something is repeating itself is the frequency, right? And this frequency in technical terms is termed as mode, right? So the mode of the data is the value with maximum frequency, right? To give you an example, let's say I have data like this, right? So let's say I have data like this, maybe 1, 2, 3, 4, 5, 5, 4, 8, 6, 1, like this, right? Let's say maybe I'll have 5 one more time, right? So here, if I make the frequency distribution table, I'll simply list down the unique values, right? I'll make it like this. This will be my values, right? And this will be the frequency of my respective values, right? So let's say 1 is one of the values here, right? This is how we used to do in our school days, right? I'll just give you a quick overview of how frequency distribution table is built, right? So this is 1, this is 2, right? 3, 4, 5. These are 5 unique values. We have 6 and 8 as well, right? So 1 is appearing how many times? This is 1, and this is one of the ones. It is appearing 2 times, right? How many times 2 is appearing? This is 1 and only 1, right? So 2 is appearing only 1 time. How many times 3 is appearing? This is 1 and okay, no more 3. So again, 3 is also appearing only 1 time. Let's talk about 4. How many times 4 is appearing? This is 1, this is 2. 4 is appearing 2 times, right? Let's talk about 5. It's appearing 1, 2, and 3 times, right? So 5 is appearing 3 times here. Let's talk about 6 here. 6 is appearing only once, right? And about 8 is also appearing only once. So if you see which of these values has the highest frequency, maximum frequency, right? So maximum frequency is maximum value in this frequency column, right? This value is 3, right? Maximum value in the frequency column is 3 here. This is the value, right? And what is this is the frequency, right? How many times it's appearing? Which value is appearing? 5 is appearing, right? Hence 5 becomes the mode of this data, right? Value with the highest number of frequency, right? So this is how the mode is defined, right? And these three collectively are termed as central tendency. And these are very important figures to get an idea of what kind of data you're dealing with. All right. So this is how, so these three terms becomes important, right, in statistics. This is the first thing that you're going to calculate on any data, right? This falls into the window of descriptive statistics, where you get a brief description of your data, right? And mean, median, and mode are three different figures that can give you a mathematical description of the data, right? There are a lot of other things, those are included, right? So for example, we have moments as well, percentiles as well, right? Quartiles as well. Everything is included in it. Right, so we'll see this. Don't worry. In the next session, we'll see that part, how it's included. All right. So yes, guys, I think this is all for today's session. All right. And in next session, we'll be discussing about moments. Right. Moments will consume one single session, right? And it's a little complex. So it's advised to everyone to, go through all the previous lectures that have been covered up till today, right? Go through these lectures before attending the next session, right? Which will be on next Saturday, right? So we'll discuss about moments. There are basically four moments, right? The first moment is called mean. This is the first moment. Second moment is called the variance, right? The third moment is basically the skewness of the data, right? And fourth moment is kurtosis, right? So we'll discuss about these four terms, and these will describe, or these figures will give you almost, a lot of information about the data. All right. All right. So let me, so this is for the next session. All right. If any one of you want to, go through before attending the session, you're free to do that. All right. So okay. So all right. So I see a few of you are confused between nth largest value, what this value is, right? So basically, let's take a small data set. I think that will help you to understand this in a better way. Let's say we have 10, 15, 20, then we have 13, 12, 18, right? Like this. So we have 1, 2, 3, 4, 5, 6. Total 6 elements in my data, right? Now, let's say if I ask you what is the first largest value, tell me in the chat section, right? What is the first largest value, especially who is confused where these values came from, right? Tell me about the first largest value, right? So the first largest value is 20 here, right? Better approach is, instead of, searching for values, it's advised when we are working on, let's say, first largest, it's advised to sort the data in descending order, right? So my first 20, 18, 15, this is 13, 12, and 10, right? So this is sorted in descending order, right? Now, if I ask you what is the first largest, you directly say 20, right? What is second largest value? It's 18, right? What is the third largest value? This is 15. What is the fourth largest value? Right? This is 13. And so on. Right? Fifth largest, and so on. So here, these are basically the values from the data that we have taken, right? So these values are basically from the data that we have taken, which is the salary column, right? What is the highest salary? This value is the highest salary, maximum salary, first highest value, right? This is the second highest value someone is trying, right? So these are basically the salary figures people are drawing or people actually have, right? First largest, second largest value. These are all these numbers are, can easily be found on the data, right? You'll not find numbers between these two, but in percentiles, you'll find numbers between these two, right? So this is how the largest and smallest can be understood. All right, so those who are waiting for the link, please wait for a few more minutes, right? Let me clear the doubts, then only I'll share the link. All right, so of course, the lookup functions are not covered. We'll cover that in the next session. Right? Any breaks for Christmas? You're advised to check your calendar for the same, right? So assignments for this week, I'll upload that on GitHub link, right? I have assignments ready for, ready to be uploaded. So I'll upload this on GitHub. You check your GitHub link by tomorrow morning, right? You can check this GitHub link by tomorrow morning. You'll find additional files uploaded, right? I've prepared it for if and else, right? I've prepared it for average if, right? Sum if, count if, all these count if, right? I've prepared this. I'll upload it. You can check the same on your GitHub link by tomorrow. All right. So what are we checking using exclusive? So see, this is basically one method of calculating percentiles, right? And inclusive is not minimum and maximum. Inclusive is all the values inclusive of minimum and maximum, right? If you're getting this, if you're having this confusion at this stage, I would advise you to go through this session at least 2 times once this is uploaded, right? Go through this session 2 times. Because if you're having this confusion that inclusive is only minimum and maximum, right? Inclusive is not only minimum and maximum. Inclusive is all the values along with the minimum and maximum, right? In exclusive, all the values are present, but minimum and maximum values are not present. Right? So assignments are not to be uploaded. These are for self-evaluations, which means I'll share the questions by tomorrow morning and I'll upload the solution on the same GitHub link 1 week after, right? So maybe after your next session, I'll upload the solution to the assignments, right? So you don't have to worry about it. You can self-evaluate yourself if you're getting the correct answer as mentioned in the sheet that I'm going to upload, right? Your answer is correct, or you can match the formula as well. All right. So yes, guys, with this note, let's wrap up the session for today. Let me share the GitHub link very quickly. Right. So this is the GitHub link where you'll find all your assignments and data sets. Right. You're expected to keep this link intact. All right. So yes, guys, with this note, let's wrap up the session for today. I thank you everyone for joining the session and you have a good night. I'll see you next weekend at the same time.